Welcome to Exercise 2 of the iMachining Professor Jumpstart series, iMachining of a bracket. This example illustrates the use of InventorCAM's iMachining technology to machine the part shown here. In this video, you will see standard 2.5D toolpaths, as well as 3D toolpaths to aid in the complete CNC programming of this part. Like in Exercise 1 of the series, the machining will be performed on a 3-axis CNC machine, only this time, we will use two setups, machining both sides of the part. First, we'll need to open our example InventorCAM part. Please note that the example file called iMachining1.prz will be included with this interactive Jumpstart PDF and can be opened by simply clicking on the part name inside the PDF. For 2.5D customers without HSR and HSS, please open the iMachining1 25D only.prz example that does not contain the 3D operations. Inventor will automatically open with the CAM part already programmed in InventorCAM. We are simply going to show you the operations that were created to perform the machining of this part. The first two iMachining operations perform the cutting of the outside shape of the part. Double-click on iRough Outside in the CAM Manager to open the iMachining operation dialog. By clicking on the Show button in the Geometry branch, we can see that two chains are defined, with the first being the stock boundary, and the second being the profile around the part. The stock chain was marked as open, which specifies the tool should approach from the outside, collapsing in towards the part profile. We are using a 1/2-inch diameter end mill. We also have a -25 thou delta depth, so the tool machines deeper than the part. In the Technology branch, we can see that this iRough operation has a 10 thou allowance on the wall. Let's click Simulate and take a look at the toolpath at work. Using the default HostCAD mode, we see that the corners are cleared first during simulation, and then the entire outside contour is machined. Using Solid Verify, let's watch the tool move through the solid stock material in 3D. Let's exit the simulation and take a look at the next operation in our CAM Manager. To create this iFinish outside iMachining operation, we've simply used the Save and Copy function that we see here in our current iMachining operation dialog. Click Exit and open the following operation. iFinish was chosen for Technology. When we look in the Technology branch and under the iRest Data tab, we can see that the previous iRough outside operation appears in the parent operation combo box, meaning that the technological parameters of the current operation are inherited from the previous parent operation. Under the Technology tab, notice how the wall offset now has a value of 0 and is blocked from being changed. This iFinish operation will use the same tool and have the same -25 thou delta depth. Let's click Simulate to view our toolpath. First, we'll use HostCAD. Then, we'll look at the machining of our part in Solid Verify. Let's exit our simulation and operation dialogs. The next two iMachining operations perform the cutting of the 5 circular through pockets. Double-click on iRough Through Pockets in the CAM Manager to open the iMachining operation dialog. By clicking the Show button in the Geometry branch, we can see that the 5 chains are defined to represent the 5 closed pockets. Since the pockets are closed with no pre-drilling or entry chain defined, helical ramping is used to enter the bottom of the pockets. Again, we will be using a 1/2-inch diameter end mill, as well as have a -25 thou delta depth, so the tool machines deeper than the part. In the Technology branch, we can see that this iRough operation has a 10 thou allowance on the wall. Let's click Simulate and take a look at the toolpath. In HostCAD, we see that the tool performs a helical entry into each pocket and clears out the necessary material. Let's also look at the simulation using Solid Verify. Exit the simulation and operation dialogs and open the iFinish Through Pockets operation from the CAM Manager. This operation will finish the through pockets. iFinish is listed for technology. Also, note that the previous iRough Through Pockets operation appears in the Parent Operation Combo box under the iRAS Data tab in the Technology branch. Under the Technology tab, we'll see the wall offset has a value of 0. This iFinish operation will use the same tool and have the same negative 25 thou delta depth. Let's click Simulate to view our toolpath. First, we'll use HostCAD. Then, we'll use Solid Verify to view the tool moving through the solid stock material. Let's now exit our simulation and operation dialogs. This next HSR operation will perform the rough cutting of the 4 large chamfers on the ribs of our part. Double-click on HSR Rough Chamfer in the CAM Manager to open the operation dialog. We can see that the target model is defined as our geometry. Again, we will be using our 1/2-inch diameter end mill. In the Constraint Boundaries branch, we can see that 2 boundaries are picked off the edges that make up the chamfers. In addition, the tool relation is set as centered. In the Passes branch, we'll see that a 50 thou step down is used and the surfaces will have a 5 thou allowance. Let's click Simulate and take a look at our toolpath at work using the HostCAD mode. We see that the tool approaches the first chamfer by helix ramping and tapers with each step down to remove the necessary material. It then rapids over to the second chamfer and performs the same toolpath. Now, let's exit the simulation and operation dialogs and look at the next 2 operations in the CAM Manager. These next 2 iMachining operations perform the cutting on the 3 semi-open pockets and 7 closed pockets. First, let's take a look at the iRough Pockets operation. By clicking the Show button in the Geometry branch, we can see that all 10 of these pockets are located on the same Z level. This means they all have the same pocket depth and can all be machined in this one operation. These first 3 chains have edges marked as open and wall, allowing the tool to enter from these edges. 4 of the closed chains use the through pockets as an entry chain. The last 2 chains, labeled 6 and 7, are simple closed pockets and the tool will enter them using helical ramping. We are going to switch tools for this operation since the bottoms of the pockets all have a radius. We will be using a 3/8 inch diameter bullnose mill with a corner radius of a 1/16 inch. In the Technology branch, we can see that this iRough operation has a 10 thou allowance on the wall. Let's click Simulate and take a look at the toolpath. In HostCAD, we see that the tool approaches the first 3 pockets from the outside. The tool enters the remaining pockets either by entry holes or helical ramping. Take notice of the toolpath and how these pockets are cleared with iMachining's patented morphing spiral technology. Now, let's view the simulation using Solid Verify. Exit the Simulation and Operation dialogues and open the iFinish Pockets operation from the CAM Manager. This operation will finish the pockets. iFinish is listed for technology. Also, note that the previous iPockets operation appears in the Parent Operation combo box under the iRest Data tab in the Technology branch. Under the Technology tab, we'll see the wall offset has a value of 0. This iFinish operation will use the same tool as before. Let's click Simulate to view our toolpath. First, we'll use HostCAD. Then, we'll use Solid Verify to view the cutting tool in 3D. Let's exit our Simulation and Operation dialogues. The next operation in the list we'll be looking at is HSS PC LIN Faces. This HSS operation will perform the finishing cut on the 4 large chamfers of the part ribs. In the Geometry branch, we can see that the chamfer faces have been defined. Like the previous pocket machining operations, we will use a 3/8 inch diameter bullnose mill with a corner radius of a 1/16 inch. A simple linear strategy is used with a 20 thou maximum stepover. As you can see here, customized linking is used to allow short repositions and smooth transitions when starting the cut. Let's click Simulate to look at our toolpath at work using the HostCAD mode. Next, let's look at the tool finishing the faces of the 4 large chamfers using Solid Verify. Now, let's exit the Simulation and Operation dialogues. Finally, let's switch over to Mach 2 to see how we will machine the other side of this part. The first iMachining operation under Mach 2 finishes the bottom ledge on the underside of the part. Double-click on iRough Face Back Ledge in the CAM Manager to open the iMachining operation dialog. By clicking Show in the Geometry branch, we can see that 2 chains are defined, with the first being the stock boundary and the second being the bottom of the floor radius. The stock chain is marked as open. We will be using the 1/2 inch diameter end mill for this operation. We can see that the milling levels have been selected in the Levels branch. Now let's simulate our toolpath. In HostCAD, we see that the tool begins at the stock chain marked as open and collapses in towards the floor radius. The radius is not machined at this stage. Let's also look at the simulation using Solid Verify. Let's now exit the Simulation and Operation dialogues. This next iMachining operation machines away the excess material from the center through hole of the part. This excess material was used for clamping from the first side under Mach 1. Again, to open the iMachining operation dialog, double-click on iRough Back Center Hole in the CAM Manager. By clicking Show in the Geometry branch, we can see that a single closed chain is defined. Again, we will be using the 1/2 inch diameter end mill. We can see that the milling levels have been selected in the Levels branch. In the Technology branch, we can see that a 10 thou allowance is being used for the wall since the wall was finished during the topside machining stage. Let's click Simulate and take a look at our toolpath. In HostCAD, we see the tool performs a helical entry and clears out the excess material. Let's also look at the simulation using Solid Verify. Let's exit our Simulation and Operation dialogues. This iMachining operation finishes the circular face on the underside of the part. Double-click on iRough Face back in the CAM Manager to open the iMachining operation dialog. In the Geometry branch, we can see two chains are defined, with the first being the outside boundary of the face, and the second being an offset edge created in Sketch 1 in the assembly. The first chain is marked as open, and the second offset chain is closed. The 1/2 inch diameter end mill will be used again for this operation, and we can see that the milling levels have been selected in the Levels branch. Now, let's simulate our toolpath. In HostCAD, we see that a spiral toolpath is performed from the outside, collapsing towards the inner chain. Let's also look at the simulation using Solid Verify. Finally, let's exit the simulation and operation dialogs. This last profile operation will finish the 1/4 inch floor radius on the underside of the part. First, double-click on the operation name in the CAM Manager to open the dialog. In the Geometry branch, we can see the chain is defined as the bottom edge of the radius. For this operation, we will use a 1/2 inch diameter ball mill, and the tool side will be set to center. During simulation, we will see the 5 thou floor offset is left after the first roughing pass, and then removed by a finishing pass. Also, take notice that a 10 thou arc is being used for lead in and lead out in the link branch. Now, let's look at our toolpath at work. Click Simulate, and then play the simulation in HostCAD. Next, let's use Solid Verify to view the cutting tool as it finishes the 1/4 inch floor radius on the underside of the part. And this concludes Exercise 2 of the iMachining Professor Jumpstart series, iMachining of a bracket. Thanks for watching. We hope that you've found this example illustrating the use of InventorCAM's iMachining technology to be very helpful. Please stay tuned for Concluding with iMachining Professor in Chapter 7 of the Interactive Jumpstart PDF. There, you'll see another video tutorial collection that will provide you with further knowledge and practice with InventorCAM iMachining.